Hi, I am Dr. Riskunapal, Professor of Science Engineering Department, Hindustan College of Engineering and Technology, Kanpur. Today we are going to see process and operating system. Process plays a vital role in operating system. Operating system manages in the concurrent execution of process. Okay, so a process is nothing but a program in execution is called as a process. Okay, so we are having certain terms like jobs, process, threads, all those things comes in the operating system. So we might have doubt in that area because job and process both are same. There is no difference in that. But when we are coming to a process and thread, there is a slight difference. Process is a heavyweight, whereas a thread is a lightweight one. And a process takes its own memory. Okay, it won't share the memory with anybody else, whereas a thread shares a common memory space. Okay, so that is the main difference between a process and a thread. And we all know that operating system execute a variety of programs. Okay, so we have a multi-programming technique here. We are having a multi-program that can be executed at a single time. So uh, basically it is divided into two ways. One is batch system, another one is a time shared system. So in the case of a batch system, similar jobs are clubbed together and it will be processed or executed. Okay, whereas in the case of time shared system, okay, uh, in the case of a time shared system, every process will be given a specific time to execute. Okay, so once the time exits, automatically it will be sent to the waiting state. The other process enter into the processing or execution. Okay, so this is what we are calling it as a time shared system. Okay, so a process includes like a program counter, stack, data section, so many things that we'll see in the forthcoming sessions. And a process just like that just enters into the operating system, executes and come out. Okay, so it undergoes various states. Okay, the states may be classified as new state, running state, waiting state, ready state, terminated state, but the states are same, but the terminologies that we are using in one operating system is different from other operating system. For example, if you are using a new in Microsoft means create in Linux. Okay, so in that way it will be varied. Okay, so a new is nothing but a process is initially created for execution. So once it is created, it will enter into the execution state. Once it is executed, it will be terminated. Okay, whereas in the case of a time sharing system, if a process enters into the running state, okay, that is execution state. If its time exits, automatically it comes out of it. So the next process will enter into the execution state. Until then, the process which was executed will be in the waiting state. Okay, until it turns comes. So once it turns comes, it will be entered into the ready state. From the ready state, it will be entered into the running state. Okay, it won't directly enter into the running state. Instead, it will enter into the ready state first. From the ready state, it will be entering into the waiting state, sorry, execution state or running state. Okay. In another way, sometimes highest priority a process comes. Okay, a process is in execution. At that time, the highest priority process comes means automatically an interrupt will occur. So immediately it will be kept into the ready state. For example, if a process has 3 minutes to execute, at the end of the first minute, higher priority process enters. Immediately, it will be kept in the ready state, not in the waiting state. Okay, so that is the thing that we have to make a note of it. Okay, so immediately it will be sent to the ready state. Once the highest priority process executes, immediately this process will be given 2 more minutes to complete. So those 2 minutes will be allocated and it will complete its process. Okay, in that way, it will be executed. This is shown in the diagram. Okay, so we have a new state. When it enters into the ready state, it goes to the running state. Once it is executed, it will be terminated, exit. Sometimes a new state to ready state to running state. If it times exits time sharing system, okay, immediately it will have to wait. Firstly, it should be sent to the waiting state. From the waiting state, it will be sent to the ready state. Okay. Whereas this is another thing when it is in the running state, when an interrupt, this is what the highest priority process enters. Immediately it will be taken to the ready state and then it will come to the ready state. Okay, so in that way it will be executed. So next one is process control block. So what is a process control block? So it is a data structure. Okay, basically it is a data structure like a linked list. Okay, it is in the form of a linked list. It is maintained by the operating system for every process. Okay, the PCB is identified by an integer process ID. Every process is identified by a process ID, and this PCB keeps all the information needed to keep track of a process as listed in the given information. Okay, PCB will maintain in what are the states the process is going. So what process have to be executed next. Okay, so what are the content of the particular process, what are the data available, what is its scheduling time, everything will be maintained by PCB. Okay, so a process state is nothing but this is information maintained by PCB. Process state information is nothing but whether the process is in which state, ready state, running state, or a waiting state, whatever it may be. That information is maintained here. A program counter is nothing but it is a pointer. Okay, a program counter always points the parent process. Okay, so the parent process, a program counter is a pointer. So it is a parent process. Okay, so this parent process will contain the address of the next instruction to be executed. Okay, so this is what we have, and followed by a CPU registers. So we have a various CPU registers where process need to be stored for execution for running state. Okay, so this is what we have, and we have a CPU scheduling. So here we have a scheduling information. In the case of a time sharing system, we are following the round robin scheduling. Okay, so all those things, and we are also having a memory management information. So this will contain the page tables, memory limits, segmentation details, all those things, and it also contains the accounting information about the CPU. Okay, the amount of CPU used for process execution and the time limit, execution, ID, etc. All those things. And we are also having a IO status information. This includes a list of IO devices, okay, input output devices allocated to the process. Okay, so all those things comes under this category. So all these things. Here we have a process P0 and a process P1. So it is in the execution state and enters the PCB0 will store the information about process P0. PCB1 will store the information about P2. The information is what we have seen, all those 10 informations. Okay. And we have a process scheduling queues. So we have basically three types of queues: job queue, ready queue, and device queue. Job queue refers to that it contains set of all process in the system. Okay, so all the process about which process is to be executed. Ready queue is the number of processes which are residing in the main memory, which is ready and waiting to execute. Okay, what we can say, job queue is whenever new jobs or new process are created, the set of process we call it as a job queue, and the process which enters into the main memory, which is in the ready state. Okay, so and finally it enters into the waiting state to execute. And a device queue is nothing but a set of process which is waiting for the input output device. So this is what we have. It is in the form of a linked list. Okay, so we have a ready queue, PCB1, PCB2, all those things. So everything is mapped. Okay, it will start from the header, move on to the B3, followed by the next process. All those things will be uh, depicted in this picture. So this is the representation of process scheduling. So generally, all the process enters into the ready queue. Okay, it is scheduled by the CPU scheduler. Once the input-output request is granted, so the process will be completed and it will enter into the ready queue. So if the time slice is expired, again the process enters into the ready queue. Similarly, if a child executes, okay, so it also enters into the ready queue. Wait for an interrupt. If there is any interrupt occurs, there also we have the problem of not execution. So immediately it enters into the ready. So we have a long-term scheduler and short-term schedulers. So in the case of a long-term scheduler, it selects the process that should be brought into the ready queue. A short-term scheduler, which is also called as CPU scheduler, it selects which process should be executed next and it allocates the CPU. So we are also having a medium-term scheduling where partially executed processes are swapped in and swapped out of the CPU. So a short-term scheduler is always invoked very frequently, even in milliseconds. Every milliseconds it will be invoked, whereas long-term scheduler is invoked very infrequently. For example, it is invoked per second or per minute, whatever it may be, and it is very slow. So the long-term scheduler controls the degree of multiprogramming. That is the most important thing. And a process can be described in two ways: input-output bound process and a CPU bound process. In the input-output bound process, the CPU spends more time doing input-output than computation. Okay, so here we have a many short CPU bursts will occur in the case of input-output bound. When you are coming to CPU bound process, spends more time doing computation. Very few long CPU bursts will occur here. Next one is context switch. In CPU switches to another process. Okay. So in the case of time sharing system, we are switching one process to another process frequently. The time must save the state of the old process and load the same state for the new process. So what it should do is, so up to what level the process is completed, so at what time it completed, so how many times left to complete the process, everything will be maintained by the CPU. So we have a context which time is always overhead. The system does no useful work while switching. So when a process is in execution and frequent switching is occurring, so it won't do anything. So time dependent on hardware support, it depends on the time. So when I'm talking about process creation, parent process create children processes, which in turn create other processes, forming a tree of processes. So we have a resource sharing. Parents and children share all the resources. Children share subset of parents' resources. Only resources are allocated to parents, and children are using the parents' resources. Whereas parent and children share no resources. Okay, there are certain situations where both the parent and child process will share no resources but execute. Okay, and execution refers to that parents and children execute concurrently. Okay, but the parent will terminate after all the children terminates. Address spaces, children use the duplicate address of the parent, and children has a program loaded into it. Okay, so it uses the address space of the parent. The most important thing. And the process termination refers to that. The process execute loss statement and asks the operating system to decide it. So after executing all those things, if the process is completed, operating system have to decide, not the other systems. Okay. Or otherwise, it can make the data to wait for a long time. Output data from child to parent. Okay. If the parent is waiting for the output given by the children, so it has to wait until the children executes. Once it gets the data from the children, automatically it will be aborted or sometimes terminated. Okay, parents may terminate execution of child process. if a parent want to exit before child process executes, so immediately it will be aborted. Okay, so that's what we have. Uh, child, it is occurring in certain scenarios. Children has exceeded allocated resources, and the task assigned to child is no longer required. I hope you might have understand what is the process, and thank you.